Generally, a battery bank consists number of cells, and each cell contains anode, cathode, and electrolytes. Now you can see there are three pictures. So in this picture you can see this is the battery bank, and other two pictures are the battery cells. So you cannot say these two individual cells as a battery bank. So a battery bank consists number of cells connected in series and parallel to get the desired voltage and capacity of the battery bank. So this is called as a battery bank. So battery bank is a combination of cells. So as I said earlier, cells are the individual energy storage devices. If we connect them in a series manner, then we call that particular configuration as a string. Then if we connect number of strings in a parallel manner, then we are saying it as a battery bank. Now, whenever we will connect the number of cells in series, then what happens? We will get the desired voltage. And whenever we will connect the battery bank in series connection, the effective battery bank voltage will be get multiplied. For example, 2-volt cells are connected and total 6 numbers of cells are connected in series. Then the output voltage will be 12 volts. If we connect this type of two 12 volts strings in parallel, then what will happen? The ampere hour capacity of the battery bank will be get doubled because it can deliver the twice the load current. So that's why if we connect the battery cells or the battery strings in parallel, then its ampere hour capacity will be get multiplied. Then with the help of these series parallel combinations, the desired battery bank voltage and battery bank capacity will be achieved. So battery bank specifications will be given in the two major parameters. First one is the battery bank voltage and second parameter is the battery bank capacity in ampere hour. So this battery bank voltage will be calculated as the cell voltage into the number of cells into the series, and battery bank capacity will be calculated as the cell capacity into the number of strings in parallel. So in this way you can calculate the battery bank voltage and its capacity. Now we will see few specifications mentioned on the nameplate of the any battery cell. So as you can see there, in general, majorly two parameters are mentioned. That is the cell voltage, that is the 2-volt in this particular example, and cell capacity. So cell capacity is 420 ampere hour at the rate of C10. So this C rating is specifying the uniform duty cycle of this particular cell. So for example, it is a C10 cell, then this particular C10 cell can be used for 10 hours. So for example, this is a 420 ampere hour battery or cell. Then C10, since it is a C10 rated cell, then you can use that particular cell to deliver 42 ampere for entire 10 hours duration. So whenever the battery manufacturer will manufacture a cell, then these type of C ratings are considered at the time of designing or the manufacturing the battery, and they are designed to deliver the a particular rated current for the particular rated duration. So how to calculate this particular current and the duration? So simply the C rating is mentioned on the nameplate. So divide that particular C10. So divide the 420 ampere hour by 10. So you will get the 42 ampere, and that C10 is mentioning the 10 hour is the total discharge or the total battery bank can deliver you the continuous 42 ampere. So this is the duration of the battery bank for a rated current. So in this way, C10, C20, C5, C3, that type of battery banks are there. So generally lead acid batteries are C8, C10 and C20 rated, and nickel cadmium batteries which are used in the different applications. So they are rated for the C5. Now, next parameter mentioned on the nameplate of the any cell, that is the ECV, electrical critical voltage. So this particular electrical critical voltage is mentioned on the nameplate of the any cell. So this voltage defines that if the cell voltage will goes below this particular critical voltage, then cell will undergoes to a deep discharge mode, and it is very difficult to revive that particular cell if it goes below the its critical voltage. So that's why it is very important to maintain this particular cell voltage above ECV. So generally this ECV is 85 to 90% of the nominal voltage of the cell. And also there are few for the specific special applications, battery manufacturers are manufacturing the electrical critical voltage, which is the 80 or 75% of the nominal voltage also. So you have to always check this particular ECV mentioned on cell, and whenever you are using this particular cells or battery banks, you have to maintain this particular electrical critical voltage. Now we will see few terminologies related to this particular battery bank. So first one is the bulk and float charging. So bulk charging is nothing but the constant current charging mode in which voltage will be gradually increased by keeping the charging current constant, and in this way the battery bank will reach to its a certain stabilized voltage, and after that we are switching the charging into float. So float is the constant voltage mode in which voltage will be constant, so that your full charge will be maintained during its operation. Now next terminology which indicates the state of the that particular cell is called as a state of charge. So what is the state of charge? It is nothing but the ratio of the present charge of the battery as compared to the total charge of a new battery. So generally, this state of charge is relates with its voltage. So for example, the 12-volt cell. So generally, the voltage of a new cell of a 12-volt cell is generally 12.6 volts or greater than that. So the state of charge of that particular cell, if it is a 12.6 volt, then the state of charge is considered as 100%. If the battery voltage or cell voltage drops, then you can see this chart. So that based on this particular calculation, this particular ratio, we can calculate the state of charge in percentage. So generally you can see there is a 10.5 volt. If the battery voltage will go below this particular 10.5 volt, then it is called as a, this particular voltage is nothing but the electrical critical voltage that we discussed in the previous slide. So you can see for this electrical critical voltage, the state of charge is 0%. So that's why whenever the SOC is 0 or the state of charge is 0%, then ECV is reached. So it is not recommended to use that particular cell below its ECV or when SOC is 0. Now next terminology related to the battery bank healthiness is the state of health. So this SOH is nothing but the capacity, ratio of the present capacity of the battery in ampere hour with respect to the capacity of the battery bank when it is a newly installed. So we are comparing this particular ampere hour capacity with respect to the current present ampere hour capacity. So as you can see these 2-3 examples in which the state of health is 100% when that particular cell is brand new. Now, if we maintain the state of charge at 100%, but due to the several reasons, the battery bank will lost its capacity. So that lost capacity is shown here. So the state of health in this particular example will be 90%. So 10% of the battery capacity you cannot use. So in this way, the state of health is calculated. So whatever the topic of this particular today's webinar is related to the battery discharge testing, in which we are going to calculate the state of the health. to predict the life curve of your battery. So that's why this particular terminology is important. Then next, internal resistance. So as we all know that every battery or cell is having its own internal resistance, and this particular internal resistance will be increased whenever this particular cell is under service. So if this particular resistance is increases, then the battery capacity will get reduced because there will be losses inside the that particular cell or battery. So that's why the internal resistance having a critical role, and it is the one of the major reason for the battery capacity reduction. Then next is the self discharge. So self discharge will take place due to the two main reasons. First one is the internal chemical reaction, and another one is the internal resistance of that particular cell. So this particular internal resistance of the cell increases, then self discharge rate will be get increases, and the capacity of that particular cell will get reduced. So this is the self discharge is also one of the major reason for the reduction in the battery capacity. Then next, the depth of discharge. So the percentage of the battery capacity that you cannot use is called as the depth of discharge. Then next, round trip efficiency. So for example, if you are providing 100 watt energy through your charger to a battery bank, and your battery bank is giving the output of 80 watt, then the round trip efficiency will be ratio of the energy recovered from that particular storage device as compared to the energy given as input to that particular cell. So this efficiency is called as the round trip efficiency. So generally, this particular loss will be takes place due to the heat loss, due to the terminations of that particular battery bank or internal resistance, increasing internal resistance of that particular battery bank. The next one is the specific gravity. So specific gravity is the weight of electrolyte compared to the weight of equal amount of or equal volume of pure water. So this ratio is used to measure the strength or percentage of sulfuric acid in that particular electrolyte. So it is periodically you need to monitor this particular specific gravity so that you can do the particular maintenance actions on the that particular cell. So specific gravity is monitored during the battery bank operation. Then now we will see what are the different conditions and reasons for the battery degradation. So generally, due to the overcharging, what will happen? This particular state of charge will be get increased beyond 120 or 140%. And what do you mean by state of charge? It is nothing but the cell voltage or battery bank voltage. So due to the overcharging, this particular cell voltage will be goes beyond its limits, and due to this increase in cell voltage, what will happen? The chemical reaction inside that particular cell will be increases its rate, and due to that what will happen? The particular ions will be get deposited on the anode, and due to that what will happen? Your battery or the cell will be get expanded, and if that particular SOC is above 1.6, then uh, your cell may get damaged. So that's why it is very important to take care of that particular cell charging. So you have to always ensure that cell will not be get overcharged. Then next, shorting. So whenever if a misplaced bus bar or any other external conductor will be placed on the battery terminals, then there might be some chances that there will be a shorting will occur. And due to this shorting, what will happen? Your cell will be get discharged without uh, without any load. So that's why this particular discharging during operation, due to this type of shorting, external shorting, what will happen? your cell capacity will be get reduced. Then next, self discharge. So as I said earlier, if your battery bank or cell is in idle condition, still due to the chemical reaction inside it, the self discharge will takes place. And due to that, what will happen? The battery capacity will be get reduced. The next parameter is related to the sulfation. So there are two phenomena, sulfation and grid corrosion. So generally this grid corrosion will occur whenever the battery acid reacts with the metal terminal of the battery. So generally this particular corrosion will be in brown, white or blue, green color. So this type of corrosion or the sulfation that will occur due to the lead sulfate crystals that are built upon on battery terminal because battery is not properly maintained. So this particular sulfation will be in gray color. So due to this type of sulfation or grid corrosion, what will happen? The battery will feel some stress whenever it is connected to the loads, and also it will there is certain external resistance will be added in the circuitry, and due to that the capacity will be lost. Next, the capacity loss. So generally due to the aging effect or due to the whenever the your battery bank cells are used in the service, then due to that what will happen? The capacity will be get reduced due to the internal heating. So there are several parameters will causes the capacity loss in the battery bank or cells. Now we will see what are the different tests conducted on the battery for the its maintenance or checking its healthiness. So generally there are different tests are conducted on the battery to check the healthiness of the battery bank. So you can see this particular list in which different parameters are mentioned and what are the different equipments you require. So in this particular battery test equipments, today we are going to discuss related to this discharge testing, in which we will use a battery loading unit, or it is also called as a battery discharge unit. Now we will see what is the actual capacity or the battery discharge test. So battery discharge test, it is the one of the only test used to determine the actual capacity of the battery bank, and it is a very essential part of the battery maintenance because we will get an idea how much battery capacity is present, because during its entire operation the battery capacity will be reduced over a period of time. So that's why it is very important to check, because battery bank is very critical uh, energy storage device which is used in the different power applications, and whenever there is a shutdown or the disconnection of the your mains power supply, then battery bank is the only reliable source to do your maintenance or further restoration activities. So that's why it is very important to ensure that this battery bank is delivering the power to your loads and it is having a proper capacity. So that's why battery capacity test is very important. It will help us to determine the life curve of the battery. You will get to know when you have to replace battery or cells. With the help of this particular discharge test, you can locate the weak cells, then faulty inter-cell connectors, and you can replace that particular weak cells to avoid the further damage to the battery bank. Then this is the only accurate method to check the battery bank healthiness and improve the battery bank life by maintaining its charging and discharging cycle. So this is importance of the battery discharge test. Then this particular test you need to conduct. Generally, this particular battery discharge test will be conducted annually. Then this particular discharge test will be conducted by discharging the entire battery bank's energy for a certain period of time. Then next, you have to compare these particular results with the previous ones to know the healthiness of the battery bank. Now we will see different IEEE standards used for the battery discharge testing. So first, IEEE standard, it is used to this particular standard has the guidelines related to the maintenance and related maintenance of the lead acid batteries. So in this particular standard, if you can go through it, then you can see the test interval is mentioned like that 20% of the expected service life or within 1 year you have to do the battery discharge testing. Similarly, for sealed lead acid batteries or the VRLA batteries, world regulated operated batteries, then you require this particular IEEE 1188 standard. So if you refer to this particular standard, you will see the different guidelines related to the battery maintenance has been given, different calculations related to the discharge testing or of this particular VRLA batteries has been mentioned in this particular standard. The test interval of this particular battery discharge test is the 25% of expected service life or 1 year is mentioned. Then next, you can refer the IEEE 1106 standard for the maintenance of the nickel cadmium batteries. Then you can refer to the IEEE 1184 for the UPS applications. You can see that these particular guidelines for the discharge testing on UPS. You can refer the IEEE 1491 for the battery monitoring guidelines. So these are the few IEEE standards used in the battery maintenance purpose, and it is also having a some part of that particular IEEE standards in which you can find the guidelines related to the battery discharge testing. Now we will see few general informations that are mentioned, and that is the common in the most of the IEEE standards. So first, there are different types of the battery discharge tests mentioned in this IEEE standards. First one is the there are first test is the acceptance test or the commissioning test. Next test is the performance and modified performance test. So this acceptance test will be conducted at the time of installation of a new battery bank. Performance and modified performance tests are carried out whenever you are using that particular battery bank is in service and it is a 1 year or 2 year, 3 year old, then you have to do this type of performance or modified performance test. Then service test, generally this type of service tests are carried out whenever you have to check battery bank's ability to meet its duty cycle. So you can see the acceptance, performance and modified performance test are used to check the battery bank's capacity, and the service and modified performance tests are used to verify the battery bank's ability to meet its duty cycle mentioned as per the battery bank OEM. Then next, the duration recommended for the performance and acceptance test is the same as that of duty cycle of that particular battery bank. So generally, as I explained you in the earlier slides, C10 rating, C5 rating, like that. That are the duty cycles of that particular battery banks. Now, the recommended duration for the modified performance test is the you have to multiply the duty cycle by the aging factor used in the sizing of the battery. So you will find this type of aging factor in the sizing of battery, and these particular parameters will be provided by the battery manufacturer. So you can use this particular technique to do the modified performance test. Now next, related to the discharge rate. So discharge rate mentioned in the several IEEE standards is that you can use this particular discharge rate in the constant current mode. So this is the most common and wide used method for the battery discharge test, and also it is mentioned in the different IEEE guidelines. Now we will see the battery discharge testing using our battery loading unit series, that is the BU series. So this is the main battery discharge unit or the battery load bank. So we are having two variants. First one is this type of LCD and keyboard variant, and this is our latest version in which we have incorporated the touchscreen operation. So now you can see the results and the real-time graphs of the voltage, current and discharge time in this within screen itself. So In previous version, you need to connect the PC software to view the real-time graphs, but now you can see the real-time graphs in the display itself. So that's why we have incorporated a new touchscreen interface to our Blue series. So now you can purchase our battery loading unit in both the options. Now we will see the features of our battery loading unit series, Blue series. So our Blue series is designed as per the IEEE guidelines to perform the capacity test. Previously, the battery discharge testing will be carried out with the help of a salt water method. So what is this salt water method? So generally, the positive and negative terminal of the battery bank will be connected to some metal rods, and these metal rods will be placed in a water tank in which the salt is introduced, and these metal rods are separated by few distance. And in this particular salt water method, the discharge current will be maintained by the proportions of the water and salt. So in this particular old conventional method, it is having some limitations. For example, this particular salt water method, it is very difficult to maintain the constant current. Then whenever this constant current will be get reduced, or the if it is get increased, then what you have to do, you need to change the water or salt proportions. For that, you have to take a pause in that particular test. So that's why the test duration and the constant discharge current will not be maintained properly in this particular saltwater method, and that's why you will get improper results in this particular saltwater method. Also, in this saltwater method, you need to use the clamp meters to take the readings of discharge current. So due to this particular dependency of on the manpower, it may introduce some errors at the time of noting down that particular results, because some may note down the current on the positive terminal, some may note down the current on the negative terminal. So that position of that particular current clamp is not proper. So that's why you will get the different readings at the different time intervals. So that's why this human error will cause mistakes in the overall capacity calculation. So this is a not proper way to carry out a discharge test on battery bank. So that's why we have developed the electronic battery loading unit, in which you can monitor the individual cell voltage with the help of the cell monitoring device. So we are calling that particular device as the cell mon. So during the battery discharge, you can monitor the individual cell voltage also. So you can identify the weak cells, and you can replace that particular weak cells if that cell voltage will be reduced at the time of discharge testing. Then this we have incorporated few interlocks in the discharge process, so that the process will be stopped if the string cutoff voltage or electrical critical voltage for that entire battery bank will be reached. Then our test will be paused. If you are using the cell monitoring devices and during discharge, for example, there are 110 number of cells, and the 88 number cell has reduced its voltage during discharge below its critical voltage, then our Cellmon will detect that particular drop in voltage, and it will send the command to our main battery loading unit to stop the discharge test. So that type of cell cutoff voltage interlock has been introduced has been incorporated in our battery load bank. Then next, if total discharge capacity in ampere hour has been reached, then discharge process will be stopped. And if set discharge time has been reached, then also the discharge process has been stopped. And if this particular discharge process has been stopped due to the cell cutoff voltage or string cutoff voltage, then you can replace the weak cells and you can continue the test. So continued test mode has been available in our particular battery loading units. Then next, we have incorporated safe circuit design to avoid the damage to the battery while testing. Then we have also having the assist mode to discharge that particular battery banks with the help of you can, for example, you are having a resistive load bank which is used by you previously, and you want to extend the discharge current. For example, let us take an example. If you want to discharge a 220-volt battery bank and it is having the capacity of 500 ampere hour, and uh, it is a lead acid type of battery, so discharge rate is C10 type of battery, so you have to discharge that particular battery bank at 50 ampere, and the discharge time will be 10 hours. Now if you are having a battery loading unit of 30 ampere and you are having a conventional resistive type of load banks of having the capacity of 20 ampere, then our battery loading unit can monitor the 20 ampere current from the external load, and it will maintain its current in so that you will get the total current of 50 ampere. So that type of smart feature we have incorporated in our battery bank. So our battery bank can work in conjunction with the other load banks also. Then next, you can use two numbers of blue models of scope make in parallel connection mode, so that, for example, if you want 300 ampere discharge current and previously you are using our battery loading unit having the capacity of 150 ampere, so you can purchase another 150 ampere unit and you can run that two models parallelly to get the 150 plus 150 total 300 ampere discharge current for the mass discharge. Then next, our software will automatically sort all the lagout batteries during discharging with the help of cell monitoring devices. Then you can transfer the data into the USB drive, or with the help of Wi-Fi, you can transfer the data into the PCLC. Then next, we are supplying the powerful data management and analysis software so that you can record the battery discharge, you can generate the reports in Excel or PDF or Word format. Then next, the thermal cutoff and automatic overload protection has been incorporated for the safety of the instrument. Then this particular instrument is installed on a metal frame and it is having the rolling wheels so that you can easily carry that particular instrument from one place to another. Now we will show you the overview of our old blue model having the LCD display and keyboard interface. So this is the old battery loading unit in which we are using the forced fan cooling technology. And in this particular battery loading unit, we are having a resistive banks, and generally we are discharging the DC battery banks by connecting that resistor number of resistors and making its combination automatically with the help of our intelligent processor, and we are discharging, or you can get the desired discharge current. So to for the cooling purpose of that particular discharge resistors that will be heated due to the I square R effect during the discharging, we are using the forced fans. So this is the back side and front side, and in which we are supplying the antenna for the wireless communication. And at the back side, the connections of this load bank is very simple. The positive terminal will be connected to the positive load terminal of our battery bank will be connected to the positive terminal of the battery bank, and negative terminal will be connected to the negative terminal of the battery bank. So in this way, simply you have to connect this particular load bank to the any battery bank and simply turn on this particular MCBs to, and you have to configure the different parameters in the battery loading unit. So this is our latest version in which we have incorporated the touchscreen interface and a 5-inch color display so that the real-time graphs will be shown on the display itself during testing. So this is the backside of our new model. Next, this is the picture of the cell monitoring unit supplied by the scope. So these particular cell monitoring units you can use for the discharging purpose. Each cell monitoring unit can be used for 12 number of cells. So you can monitor 12 number of cells by using single cell mon unit. So for example, you are having a 220 volt battery bank consisting 2 volt cells. So total 110 number of cells are present in your battery bank. Then you require total 10 numbers of cell monitoring units to monitor your entire battery bank cells. So this is the cell monitoring unit. Now this cell monitoring unit is having the magnets at its backside, so that you can easily mount this particular cell monitoring unit on any metal surface and simply connect with this particular number of cells with the help of this serial cable. Now, what is the application of this cell monitoring unit? So this cell monitoring unit will identify the number of it will monitor each and every cell of battery bank during discharging. It will identify the weak cells whose voltage will be dropped below its ECB, and it will pause the test. So and the software will automatically indicate you the cell numbers which are the weak. So with the help of this data, you can replace that weak cells with the new one, and you can continue the test with the help of our continued mode. So in this way, you can ensure or enhance the battery life by replacing the weak cells. What is the importance of replacing these weak cells? Generally, the weak cells will create load on the adjacent cells in the string, and whenever you will continue the operation of this battery bank with these particular weak cells, what will happen? Generally, these weak cells will damage the adjacent cells, and you need to replace the entire string. So to avoid this particular event, it will be always better to take an preventive action and identify the weak cells and replace them to save the cost, failure of the entire battery bank, and time. So this is the predictive maintenance and of that particular battery bank with the help of this particular cell monitoring unit to identify the weak cells. Now, what are the different parameters you need to configure at the time of battery discharge testing? So first one is the cell voltage. So if you are using the cell monitoring unit, then you have to enter the cell voltage. The next one is the string end voltage. So string end voltage, nothing but the your entire battery bank voltage. Next one is the cell end voltage. So cell end voltage will be automatically calculated by our instrument, and generally we are keeping that particular setting as 90% of the nominal voltage entered by you. If that particular ECB or the cell end voltage is less than 90% of the nominal voltage, then you can manually change that particular cell end voltage. Next, total number of cells you need to that will be automatically calculated by our instrument. Then next parameter is the discharge capacity. So for example, it is a 200 ampere hour battery bank, and you need to discharge the entire battery bank. Then you need to enter the discharge capacity as 200. If you want to lesser, then you can change it manually. Then next, discharge current. So discharge current will be calculated automatically if you will enter the discharge rate here, C10 or C5, then it will be calculated automatically, or you can set other to get the to set the discharge current manually. Then you can set the discharge time from 1 minute to the total 99 hours. But generally, cell battery bank or the cell types are generally C10 rated or C20 rated maximum. So you have to use this particular battery bank for 20 hours setting in the practical scenario. Now we will see the typical connections of the battery loading unit. Now here you can see the connections are very simple of battery loading unit. Connect the positive terminal of the load terminal of the battery bank, battery loading unit to the battery bank of the positive terminal, and negative terminal, load terminal of the BU to the negative terminal of the battery bank. And there is one voltage measurement cable you need to connect between positive and negative terminal. Why I have provided this type of positive negative terminal voltage measurement cable? because we are interested to measure the battery bank voltage at the battery bank terminals only. That's why we have given a separate cable for the exact measurement. Now you have to install one antenna for the communication with the laptop or PC. Then next, this is the connections of the cell monitoring unit. So you have to you can connect the cell monitoring unit, single cell mon unit, for total 12 numbers of cells. So the connections as shown here. These are the actual field connections in which the cell monitoring units and the battery loading unit has been connected to a battery bank. So in this way, you need to connect the multiple cell monitoring units as per the number of cells present in that battery bank. So here we have shown the example of a 48-volt battery bank in which total 24 numbers of cells were there. And we have connected 2 numbers of cell mons because single cell mon can monitor 12 numbers of cells. Then in the real-time software, you can see there are different results you can take. Then you can plot the real-time graphs of the voltage current with respect to the time, and you can monitor in real time in the software. Our software will give you the report in this type. So you can see at the last, you will see there is the rated capacity of 535 ampere hour. Then the discharge capacity is 534.1 ampere hour. So total discharge percentage is the 99.83. So this is the total capacity available. So this discharge percentage is nothing but your state of health. So this is the main purpose of our test, to get this particular results. In this particular report, you will also find what is the cause of stop also. So this, since I have shown this example in which the discharge time has been completed. So in this way, you can create a particular report and you can submit it to your higher officials. Then these are the specifications of the Blue series. So our battery loading unit is operating on the 230 volt plus minus 10% AC power supply. Single phase AC power supply is required for the operation of the battery bank. Now, why we require this 230 volt external AC main supply? Because there are number of fans are used for the cooling purpose. That's why we require this supply voltage for the operation of our battery bank. Then these are the accuracy and resolution. You can refer to this particular chart. Then next, we are having the several models. So these are the few standard models which we are offering. Other than that, if you want the other models, customizable models as per your several battery banks present in your plant or your substation, then you can put that inquiry to us, so that then we can manufacture customized model as per your requirement. Now, always you have to keep one point in your mind, that any single model is having the different voltage ranges. For example, if you are having a 48 volt and 220 volt and 110 volt battery bank present in your substation, and you want minimum 100 ampere of discharge current, then you have to opt the model called as the Blue 2252, in which both 48, 110 and 220 volt settings are available. So in this way, you can choose from the standard models, or if your desired discharge current is not fitting in a standard model, then we can provide you the customized models also. Now, what are the applications of this particular battery discharge units? So as you all know, wherever there is a battery banks are present, you can use this particular battery discharge kits. So this particular product is suitable for small battery manufacturers, power utilities, transmission, distribution, generation plants, solar, hydro, wind, thermal, different industries like cement, chemical. Then the testing service providers can also procure this particular battery discharge kit to provide the battery discharge testing service. Then railways, telecom operators, where the battery bank is the main source or the UPS is the main source. Then next, data centers, different industries, then power backup stations, EV suppliers, energy storage plants, then big hospital, colleges. So these are the different applications of this particular battery discharge loading unit you can procure. So that's the end of this particular technical presentation. Now, if you having any queries, technical queries related to this particular product, then you can send us an email on ps@scopetnm.com. If you are currently using our battery discharge kit, then you can contact us on the after related to the after sales service related information. Then you can contact us on the service@scopetnm.com. Then if you want this particular product, if you want to purchase, or if you want any further offers or any information, then you can send us an email on marketing@scopetnm.com, and you can get the product details or other our test and measurement equipment details on our website www.scopetnm.com. So thank you all of you for your patient listening. Now we will see, you can put your questions on chat box.
Thank you, Vishal sir. Indeed, it was a very informative session. I hope we all gathered a lot of insights from the webinar. And now the house is open for questions. So if you guys have any questions or any queries, you can put it up either. But I would just suggest you can put it in the chat, and Vishal sir will take it one by one.
Okay. So there is one question from the Mr. Ankur Gupta. What about lithium-ion batteries? So related to the lithium-ion battery, generally the lithium-ion battery manufacturers will give you its discharge rate, its capacity, and you can refer the standards related to the discharging process. So generally related to the lithium-ion batteries, they are generally C3 or C1 rated. 1 hour or 3 hour duration they are designed. So you can also use our kit, but simply you have to calculate the discharge current with the help of battery manufacturers data, and you can select the battery discharge model from us. I hope this explanation clears your doubt. Cell monitoring device will monitor the voltage, but okay. So there is another question. Unit monitors the voltage, but how we can monitor the current? So, sir, actually the current will be measured by our battery loading unit itself. So your total discharge current will be measured by the battery loading unit itself. So you cell monitoring will only monitor the individual cell voltage, because the discharge current will not be different across the different strings. So that's why you do not require the individual current monitoring device for individual cells during discharge process. There is another question from Mr. Sanjeev Kumar. Which model is suitable for the 1350 ampere hour and 220 volt DC bank for the C10 test? So as per the C10, related to the C10 batteries, you required, sir, actually 135 ampere discharge current. So for that particular application, we are having one model called as the Blue 2252. I will also mention that model in chat. Blue 2252, in which you can get the 220 volt and total 150 ampere discharge current. Then there is another question from Mr. Santosh Kumar. In water discharge test, what should be the water and salt ratio? Sir, actually in the water discharge test, the water and salt ratio, so that ratio you need to adjust by the at the time of discharge. And first you need to put that positive and negative rods in the water and in the solution of the water and salt, and you have to uh, change the concentration of water and salt by monitoring the discharge current. So if you want to increase the discharge rate, then you have to either add water or salt. You have to adjust that particular water salt ratio by monitoring the actual discharge current or the real time discharge current. So actually that particular process is very hectic. So that's why we have developed this type of electronic battery loading unit, in which you have to simply configure the voltage, current, discharge time, and the kit will perform the entire test without any uh, monitoring of any operating personnel. So that is the main advantage of our battery discharge test.
Actually, there's one more question from Mr. Ankur. So, how can we test 2-volt VRLA cell?
For 2-volt VRLA cell, so you want to test discharge, you want to perform the discharge test on 2-volt VRLA cell, then we can provide you, sir, a cell charging discharging small device in which you can charge that particular cell and also perform a discharge test on a 2-volt or 12-volt cell. So that type of small unit we can develop with the help of our R&D, and we can provide you that type of cell discharge device also. I hope this will clear your doubt. Yes, sir, that 300 ampere hour is also possible. So for that 300 ampere hour, you require 30 ampere. So that is our maximum 30 ampere we can develop for individual cell discharging. That is possible, sir. If anybody is having other questions, then you can ask. Actually, sir, there is another question from Ankur, sir. Is it independent of battery chemistry? Actually, sir, this discharge current or the discharge rate, this type of things, uh, also battery manufacturer is deciding the battery chemistry and its discharge rate or the discharge rate. That type of parameters will be considered at the time of battery designing. So if the battery chemistry changes, then C rating of that particular battery bank will changes, and based on that C rating, we need to set the different discharge rate and different discharge duration. So our battery loading unit you can use for any battery type, but only you have to set the battery duration and battery discharge current based on the information from that battery manufacturer. Okay. Is there any further question from anybody? I hope my answers are. I hope my explanation has answered your all the questions. So if there are no further questions, then we will end this particular session. So we are requesting you to register whenever we will send you the emailers related to the our next upcoming webinar on the first Thursday of the next month. So from the next month we will discuss related to the circuit breaker testing. So it is requested you to register for that particular webinars whenever you will receive a email from us. So thank you all of you.
Hello,
Hello.
sir.
Yes.
Sir, I want to know how can I find efficiency of battery? Battery efficiency, sir.
Battery means that round trip efficiency.
Yes, sir. Means what is the efficiency of battery? How can I find?
With the help of this discharge test.
This is discharge test.
Okay. So let me share that particular slide in which I have mentioned our test report.
Okay.
So in this way, our test report will be shown. Generally, you have to set the discharge current and discharge duration at the time of starting of the test. So for example, I have shown one report in which 535 ampere hour is the rated capacity of that particular battery bank. Okay, and we are it is a C10 rated battery, so that's why we set the discharge current as 53.5 because 535 divided by 10, so 53.5 ampere is the discharge current. Now the discharge duration is the 10 hours. So we have discharged that particular battery bank at the constant current rate of 53.5 ampere, and we have run that particular discharge test for entire 10 hours. So here you can see the setting discharge time. So for entire 10 hours, if we have conducted that particular discharge test, then at the time of that particular end of that particular test, the calculated discharge capacity is the 534.1 ampere hour. So your total state of health of that particular battery bank is nothing but the 534.1 divided by 535 into 100. That is the percentage state of health of that particular battery bank. So 99.83 is the actual capacity of that particular battery bank at, at present as compared to the capacity of new battery bank. So in this way, you can find out the present healthiness of that particular battery bank with the help of our software or battery bank.
Okay, sir. Thank you.
I hope these calculations and everything is clear to you now.
Uh,
Okay.
There's one more question come from Mr. Ankur.
Okay. So there is one question from Mr. Ankur sir. So sir, Salmon comes with glue or we have to purchase it separately? So actually different customers are having different types of battery banks. So for example, somebody has 48 volt, somebody has 220 volt, somebody has 380 volt. So based on that battery bank voltage, number of cells are different at different customer premises. So that's why we are supplying that particular cell monitoring unit as optional, because that cell monitoring device quantity is different for different customers. So that's why a single cell monitoring unit can monitor only 12 number of cells. So based on number of cell monitoring, the number of cells you want to monitor, we are supplying that particular cell monitoring unit as optional. So in offer, generally we are providing a per unit price of battery loading unit and per unit price of cell monitoring unit. So you have to decide how much cell monitoring unit you require based on number of cells present in your premises. Okay, so we will end this particular session. So thank you all of you for joining us. Now we are requesting you to join our upcoming webinars related to the circuit breaker that will be conducted on the first Thursday of the next month. So thank you all of you. Thank you for your participation.